Hello, algebra student, and welcome to the very beginning of Unit 4. And if you're wondering, why in the world are we in Unit 4, Miss Glessner? We just finished Unit 2. My answer to you is, it's 2020, it's COVID. There are no rules. The only rule of 2020 is there are no more rules, right? Or at least the rules that are traditional rules don't apply. We are not going to do Unit 3. Unit 3 has some good stuff in it, but it's not crucial that we cover the material in Unit 3. You will do just fine in Units 4 and 5 and 6 and 7 and 8, 9, 10, 11, 12 without covering Unit 3. So all the algebra teachers here for 8th grade, we all talked and decided it was a unit that could be skipped if needed, and it's needed because time is of the essence. So we are in Unit 4. This is Lesson 1, and it's called Finding Slope. This won't be your first experience with slope. I would imagine you worked with slope last year in pre-algebra and possibly even in 6th grade when you were doing your 6th grade advanced math. Slope, otherwise known as steepness of a line, right? There's a couple different kinds of slope we're going to learn about here. Let's see where we're at. Let me zoom in just a touch. I guess that's as far as I can go. All right, we're going to take some notes. So you should have your notebook. You should start a new page, call it Unit 4, and Lesson 1. What is slope? It is the constant rate of change between points on a line. The constant rate of change between points on a line. All right, so rate of change, I know you've worked with that in the past. It's the same thing as slope. The next bullet point they have us talk about, let's fill in the blanks. It is a ratio, which means a fraction, of the rise to the run of a line. So it's a ratio, which means a fraction, where we look at how the rise is changing. That goes on top. That's your up or down movement. And then the number that goes on bottom is the change in the run, which is your side-to-side movement. All right? The variable that they choose to use for slope down here, the third bullet point, known as variable m. Slope is represented as an m. All right, there are 4 different kinds of slope. Always consider slope like you would be reading a sentence, starting on the left and working toward the right. So going from left to right, if your line is going in the up direction, pointing up to the right, we call that positive slope. If from left to right, you notice your line is going down, so pointing down to the right, that is called negative slope. If your line is perfectly flat, this right here, this nice horizontal line, doesn't go uphill, doesn't go downhill, that is called zero slope. Or if you have a line that is perfectly straight up and down, perfectly vertical, like a cliff, we call that undefined. Undefined. And I always tell kids, kind of think of it as like if you were on I guess a skateboard, or I guess this guy's on like a snowboard, but if you were on a skateboard and you were skating along and you came to a cliff that dropped straight off and you went off that cliff and went splat at the bottom, you would be undefined, right? That would be it for you, lights out. So sometimes kids get these two mixed up, which one is zero slope and which one is undefined. Undefined is a cliff. You wouldn't want to try to ride your bike down something that had a slope that was undefined, straight up and down. Okay, what you might have a difficult time seeing, I don't know I can't zoom in any further, but again, they're just showing the ratio here. So this M means slope is equal to the rise over the run, and the rise is the vertical change. Again, that's how much your line is changing in the up and down movement from one point to the next. And then the run, that is that horizontal change, that side to side movement between 2 points. So now we're going to look at some lines and we're going to see if we can write the slopes. Now, for the sake of this video and the fact that it's not ideal to record a video from your dining room table, you got to bear with me here a little bit. I'll try to make this a little bit bigger for you to see. If the line that you're trying to find the slope for does not already have 2 identified points, you need to find 2 points. So this one just so happens to have these nice points already defined for us. Somebody's already gone and put those there. But if they hadn't done that, you would find your line and you would trace it until it came to a corner on the grid and then another corner on the grid, right? So you have to find where your line intersects your grid, your coordinate plane on these corner spots. So for number 1, we have this dot and this dot. Now, again, I tend to do slope like I read a sentence, starting on the left point, working my way to the point that's furthest right. So from left to right. First of all, I would ask you this. Is this positive slope, negative slope, zero slope, or undefined? I hope you realize that is definitely a positive sloping line. That means the fraction that I'm going to write here should end up being positive. 2 positive numbers. Positive number on top, positive number on bottom. Now, the trick to doing this is to count the little squares, the jumps, if you will. So, what comes first is the rise. And what that means is, from this location, how far do I have to rise to get up to the level of the next point? So, again, we're counting the jumps. This is 1, 2, 3, 4, 5, 6. That was 7 jumps to get up there. That means my top number is a positive 7. Going in the up direction is a positive movement. Now, the bottom number is the run. That's the change side to side. So, here we are. We're trying to get over here to this right position. So, once we go up 7, what do? We go over 1, 2, 3, 4 jumps, and moving to the right is considered a positive movement, just like it would be on a number line. So we have 7 over 4, and that's it. I realize that that is an improper fraction, but for slope, it doesn't matter. You would not try to reduce that and say 1 3/4. No. Leave it as a ratio. Leave it as a fraction. What if it was like 14 over 8? If it was doubled, if you did your slope ratio and you got something like this, and it could be simplified down to 7/4, then yes, you should do that. But you should never take this and turn it into like a mixed number. So if you notice your ratio can be simplified, go ahead and do that. But otherwise, you just go ahead and leave it in fraction form. Okay, rise over run. Let's do number 2 here. Again, the points are there. They're not very dark, so I'll darken them for you. There's a point here, and there's a point here. Rise over run. Rise over run. So we go up and down first. Starting on the left, working our way to the right, we're definitely going to be going in the down movement, in the downward direction. That's going to be a negative number. Moving down is negative, whereas over here when we moved up, that was positive 7, right? This was up 7, right 4. Those are both positive movements. What you're going to see here is a negative movement. Starting here, going down to this level is 1, 2, 3 jumps down. So we went down 3, That means my rise is -3. Now my run goes over to the right, and always moving right is always a positive number. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. That was 9 jumps to the right. That's a positive 9. So again, this was a negative sloping line, and it should have a negative ratio. It should have a negative slope fraction. Can it be simplified? It sure can. -1/3 is the best representation of slope. Good. Let's take a look at number 3. Here are the dots. There's a point there and a point there. Rise over run. From this point to this point doesn't rise at all. That is it doesn't go up or down. So we say the rise is 0. And then the run, that's our side-to-side movement, is going right 1. So that's the slope fraction. 0 over 1, which is 0, right? That is a horizontal line with 0 slope. When the 0 ends up on top of your ratio, that is a slope of 0. Because if you take 0 and put it in your calculator and divide it by 1, the calculator is going to tell you 0. 0 divided by anything is 0. And remember, ultimately, ratios mean division. All right, let's do it again down here. We're on number 4. Let me darken up those points for you. We have a point here and another here. Rise over run. For the rise, well, it doesn't matter if you're going to see, it doesn't matter if we say up or down, but I'll start up and I'll work my way down. That's how many jumps? 1, 2. Did I count wrong? No. 1, 2, 3. So we went down 3. And then for my run, that's my side-to-side movement. And you'll notice there is no side-to-side movement. I don't have to go right or left. So because there is no side-to-side movement, the bottom number is 0. Now guess what would happen if you would put this in your calculator? If you were to type -3 divide by 0, your calculator would probably say syntax error or something that would indicate some sort of an error or unable to calculate. Because you cannot take a number and divide it by 0. And again, it all comes back to the fact that vertical lines are undefined slopes. So when the 0 is on bottom, that is undefined. And that would be your final answer, undefined. So when the 0 is on bottom, undefined. When the 0 is on top, slope of 0. We'll just do a couple more. Let's do number 14. Darken up those points a little bit. Now we got to do rise over run. Rise over run. Starting here, going here is going up 2. Up 2 is a positive 2. And now to the right, it's 1, 2, 3. It's going right 3. Up is positive and right is positive. And 2/3 cannot be simplified. That has a slope of 2/3. You know, if we were really being accurate, we would be saying m equals 2/3. Yeah, that would really be like the best possible way. So again, that's a positive slope, and that's a positive fraction. Good. Oh, let's do one more. Let's do number 20. 20 is down here. They give us a point here and a point here. That is definitely a negative sloping line, which means there will be one negative number in my ratio. One negative number. Set my ratio up. Rise and run. Starting on the left, going toward the right, that's going down 1, 2. So down 2 is negative 2. And now to the right, 1, 2, 3, 4 to the right is positive 4. And that can be simplified to negative 1/2. That's the best answer there. So rise and run. Do your up and down movement first, then do your side to side movement. Watch out for where the zeros might land because those are kind of like special cases. Okay, now there's one more thing they want us to practice, and that is how to calculate slope if you don't see the graph. There's actually a formula. If I could get the notes right. Here we go. So this is like the second half of the lesson. There is a slope formula, and it looks like this. Y sub 2, we call that y2, minus y sub 1 over x2 minus x1. So essentially what's going to happen now in these problems is you're going to see ordered pairs, and you're not going to see the line that's been graphed. You're not going to see these points on the coordinate plane. All they're going to give you is the ordered pair, and they're going to see if you can use the slope formula to calculate the slope. And basically what you do is you set up a subtraction problem. Now that's an A-OK way, and I will show you this way, but then I have my own way of doing it. I call it the Glessner method. I'll show you that way as well. Quite frankly, I don't care which method you use. It's entirely up to you. Let's do the slope formula first, since that's technically the curriculum. And the first thing you have to do is you have to figure out who's y2, y1, x2, x1. Well, it's quite simple. Your first ordered pair is your x1, y1. Your second ordered pair is your x2, y2. Now, you might be thinking, I'm not going to do that. I don't need to label my ordered pairs like that. Well, then I would say to you, good luck. Good luck, because it can be really tricky to keep track which number would go in which spot when you're trying to pull from here and put up here into this formula. I'm telling you, labeling these things does help. So let's set up the subtraction problem. And again, this is going to get real tricky when we start throwing negatives at you. Might want to have your calculator handy. All right. On top, we have y2 minus y1. y2 is 3 minus y1 is 1. And then on bottom, x2 minus x1. x2, the way we labeled this, is 4 minus x1, which is 1. So you set up the subtraction problem, and now you do the math. 3 minus 1 is 2. 4 minus 1 is 3, and that's your final answer. 2/3. The slope of that line is 2/3. Okay, let's do some that have negatives, because that's real life. x1, y1, x2, y2. Here we go. x2, negative 2, minus x1. I'm sorry, I said it wrong. See, it's a lot to keep track of. y2, which is negative 2, minus y1, which is 4. That goes on top. Your y's go on top, always. Now the x's go on bottom. x2 is 10 minus x1, which is negative 2. Look at that. We are subtracting that number, and that number is a negative. So subtracting a negative. Okay, negative 2 minus 4 is negative 6. 10 minus negative 2, which is the same as plus positive 2, is 12. That can simplify to negative 1/2. So you know what? This subtracting negatives can be a real issue for kids. And that's why I have my own method. And we'll get to this one here in just a minute. This is my favorite, by the way. We'll get there. Let's do a really ugly one with lots of negatives. Well, I don't see a really horrible one. Well, let's not do a really horrible one. We'll just go on and do, I don't know. Let's do 5. I don't know. I'm kind of winging it, right? Here we go. I say label. X1, Y1, X2, Y2. Here we go. Y2 is 9 minus Y1, which is 9. X2 is 3 minus X1, which is 5. 9 minus 9 is 0. 3 minus 5 is negative 2. What happens when the zero's on top, kids? That is a slope of 0. That means that if we graphed it, would be a horizontal line. There's no change in the up and down movement. The y values aren't changing. Okay? One more like that with their slope formula. We'll do number 6. Here we go. Y2 is 5 minus Y1, which is 8. X2 is negative 7 minus X1, which is negative 7. 5 minus 8, negative 3. 7 minus negative 7, which is really plus positive. Negative 7 plus, that's a 0. Oh, what happens when the zero's on bottom? Undefined. That means if we were to graph this guy, that would be a vertical line like so. Because there's no change in the y values, which means there's no side-to-side movement of our dots. It's all straight up and down. All right, so that is the slope formula. Now, let me teach you my quick little method, which for some kids is better. I'm not saying it's going to be better for you. I'm just saying it's better for some kids. We're even going to change colors here. We'll go to green. No, blue. Let me teach you the Glessner method. I like my method because it works well for kids that struggle with negative numbers. I'm just saying, I've been a math teacher a long, long time, and I might know what I'm talking about. We're not going to set up a subtraction problem. That's not how I'm going to talk you through this. Check it out. Let's start with number 9. On top goes what we call change in y. For the record, a triangle is representative of the Greek letter delta, and that means change. So the change in y goes on top, and the change in x goes on bottom. So we're going to ask ourselves, how is y changing and how is x changing? Check this out. If I look at my y's, I've got a 6 and a 5. Now follow me. If you are moving on a number line, how would you get from a 6 to a 5? From a 6 to a 5 is minus 1, right? Down 1 or subtract 1, negative 1. Now, we do it for the x's. We're going from a 5 up to a 6. How do you get from a 5 up to a 6? So that was a minus 1. From a 5 to a 6 is a plus 1. So now the bottom number is positive 1. So that means we have one negative number and one positive number. That is our slope. The change in y from here to here goes on top, and then the change in x from here to here goes on bottom. Let's do another. Change in y over change in x. Here we go. Look at the y's. How do you get from a negative 4 to a negative 4? That's a 0, right? There is no change. Okay, now we do the x's. How do you get from a 9 down to a 1? You subtract 8. Okay, well, this just happens to be a slope of 0, right? 0 in the numerator, a slope of 0. That is a horizontal line. Let's do another. My way's faster, I think. Here we go. Y's first. How do you get from a negative 9 to a negative 2? Like on a number line. How would you get from a negative 9 to a negative 2? You would go up 7 or add 7, positive 7. And then we do it for the x's. How do you get from a 5 down to a 3? You would subtract 2. That's a negative 2. That means your slope is 7 over negative 2. Notice, you guys, I'm always starting on the first ordered pair, going to the second ordered pair. First ordered pair to the second ordered pair. You have to be consistent in your movement like that. Okay, last one. Y's first. How do you get from a 6 to an 8? You go up 2 or add 2. That's a positive. And then how do you get from a 4 to a 4? That's a 0. So we put a 0 on bottom. 0 on bottom is undefined. We'll shorten it up and just say undefined, undef. All right? So I don't care if you want to use my method, if it makes sense to you, if you think that's easier, or if you'd like to set up a subtraction problem, you could do that as well. This does tend to get a little bit more confusing for kids. It's entirely up to you. But the takeaway is, can you calculate slope from a set of ordered pairs? Can you calculate slope from lines that have been graphed? And do you understand the 4 different kinds of slope? And I hope the answer to all those questions is yes. All right. Thank you for watching, and I'll see you in class. Well, sort of. Bye-bye.